Hi guys, I'm Kristaps from Ubiquiti, and I'm going to tell you about test automation in our wide device zoo. Maybe someone has Ubiquiti devices at home. Some of you? Yeah, one hand, two. Yeah, we have some, at least some. So yeah, it's nice to see also known friendly faces here, and nice that there are also someone with experience with our devices. Yeah, a little bit about me. Like I don't like to speak a lot about flashy titles or something, so I'm around just 14 plus years in the industry, 12 years from this as automation. So I just started as a Java developer, then I got into manual QA, testing, pushing buttons, and then tried automation of, oh yeah, that's very nice, that helps to solve some monkey job thing, like we can automate and make stuff better so MQAs can focus on more like exploratory testing, like real complex stuff. So yeah, so I'm here. Yeah, what I'm gonna speak about today, so about the company, so a little bit more about Ubiquiti, like what we are doing, what's the product, functionality, diversity, yeah, that comes after. Then how we standardize our device test cycle, then about challenges in between and in the end, and how we chose to solve it, our approach, and in the end I'll give it all in short summary so you can get a takeaway in short how we did it, and maybe you'll have some suggestions. Yeah, so Ubiquiti, our motto is rethinking IT. Our main goal is to simplify IT. So not just provide powerful, capable network devices, but also it's about UX as it is today, user experience. So people can seamlessly and simply buy our devices in the store or online store, and till the end when they adopt their device, their system, configure and enjoy a great internet. So our product line is quite big, so it's not just network itself. So there's Unify OS, the OS system that everything gets on top of it, access with card readers, protect, connect, and so on, several. So yeah, quite a wide stack. And yeah, like we see on the right, there's like big rack with devices. Yeah, there's big setups. There's also user setups, and like this is our main network dashboard. Like you can really see what's happening on your network, all the stats, all the users, our devices, what configurations. So it's more visible, more easier to understand, and more easier to configure. Sorry. Yeah. So we're trying to build the future of IT and license-free. But this is one of our like the main products that usually people know us by. It's our access points that look like small UFOs at venues, cafes. Anybody have seen them before somewhere? Yeah, see hands. That's nice. Yeah, so this is quite good marketing device for us. That's visible. Yeah, so as you noticed already in this big rack devices, we have a lot of devices, so we need to support routing, so we need switches for that also, and access points, so Wi-Fi, have nice coverage of Wi-Fi is available, yeah. So it's all like a big zoo. That's my first association. So it's like in a zoo. We have many animals, many ecosystems, everybody interacts in somehow together, maybe some don't interact at all. Yeah, so I was thinking that, yeah, just like a zoo, and we need to somehow manage it, right? So on the right side, you can see some main functionality that's usually for cloud gateways. So for example, this is the Dream Router 7 cloud gateway. We call them console, so that's where all network configuration is there, the stats get processed there, and we can always delve deeper into functionality in more like granular what's underneath each of those points, but this is just like overview what's there. And yeah, we can add several devices, like here is switch. We need also add access point sometimes. Maybe you have your device at one point at the house where the internet's coming in, and then you have bad coverage and like, oh, how to solve this? Like, do we add access point and more further, increase coverage, better Wi-Fi, everyone's happy, maybe some security, yeah, so we add protect cameras, and we can see what's happening inside the house, outside, so yeah, the possibilities to expand are quite huge. So this is some kind of like prosumer home setup, I would say. There are also larger setups, like Enterprise Fortress Gateway. This is all like big enterprise stuff. Here maybe you don't feel this big setup vibe, because this is more like a backbone. Yeah, but we have a lot of boards here, and usually this is for big companies, like maybe similar like here, several stories, building, several APs connected, like for example this E7 access point connected, which is also very powerful, and usually other devices are around that and in bigger setups. And someone needs 100% uptime, and it's also like a big thing for cloud computing and other network-related stuff. So yeah, we pair together devices on several layers and make redundancy. So in case something fails, failovers happen, and clients get this seamless, smooth experience. So the requirements are different, setups are different. It's like home, it's like a small office, big office, some prosumers that want super high speed. So everyone has their own wishes. Yeah, but we need to be the duck, yeah, who does all the things and make sure that it works, you know. Yeah, we need to fly, we need to walk, and we need to swim. So that's what we, the network team, I'm part of the network team, and we're trying to achieve that, to test, verify, bring exposure to defects or maybe something that could be done better, so to improve experience for clients, users, yeah, and so on. So this was already seen before, like, so all the network configurations are managed on controller. That's the console itself. This is Enterprise Fortress Gateway, we call EFG in short, that you saw before. That's the enterprise big setup that I mentioned. So this one don't have protect, so no camera. No camera application there, but it's really network capable. There maybe are some smaller companies that Dream Machine Special Edition is suitable for them. So like here it's a hard drive with protect there, so already you can save videos there of cameras. We have power over Ethernet ports that can support cameras without external power. Extra functionality, but maybe not so powerful for super huge setups. Then we have something on home prosumer side. I already mentioned like Dream Router 7. So this one is beautiful to put on the shelf at your home, and also big possibilities regards the protect, where you can put cameras, also add to it, integrated Wi-Fi, and like if you have super small home and you just need something basic, small form factor, it's Express 7, like Wi-Fi integrated, only network, yeah, basic network stuff, it works, and it's fine. So devices are like animals, like super different. Yes, like there's like elephant that is like super powerful and might be missing some agility, and this is some kind of bear cat or something like that. GPT created something like that, but yeah, maybe that could be a bear that's something in the middle that has agility and power, and the rabbit that has like super high agility and low power. Yeah, so it's different kinds of devices. So, and yeah, there's a lot of problems that potential. It's not like problems; it's more like challenges, I would say. Yeah, the challenges that comes with that, and we need to approach in a standardized way. So we standardize our console test cycle because we have like main changes that impact our product. So we have firmware changes that are coming in. So on hardware side, there's something happening, something new. And network, of course, that's the line where the beautiful UI is there, all the stats, user management, all the UX paths that gives us the smooth experience. Like for example, we standardize this process, so we have one pipeline that's for each console, like irrespective of the device. So we have firmware installation, where we check the configuration of that's for particular device, and we understand like, do we have like latest version, some new version, or we don't. So if we have a new version, we need to install that. If we don't, we can skip it. And then network installation and firmware installation is done. Network installation, it happens every time. We are networking, right? So each version when it comes out, when it's published, we install our latest version and check it. But it doesn't end with installation. Yeah, we install it, we run it, we need to check that it's on, and then comes the setup. We need to automatically set up the device. So we go through all the setup process. After that, we assume that console is set up, functional, and that's the user experience. After that, how user uses its console. And after that, becomes the test part. Yeah, that's only one box there, but we could actually expand this further. There are like API tests, like internal API, external API that you can integrate with the API key. There are adoption tests, web end-to-end tests. Yeah, there's a lot of tests that also correlate with all these devices, right? How we saw before. So we have switches, cameras, and we need to check all kinds of compatibilities with that. Access points, of course. And when the tests are done, we gather all the reports from all the tests, publish where it's needed, Slack channel this, Slack channel that, where everything needs to go. So visibility is there. And then we need to ensure that this console is reusable again. So we factory reset it. So from software side, we reset it back. So after that, it's available in the pool. So, but challenge is that you saw that there are many devices, smaller, bigger, all kinds, and this needs to be done for all devices. Yeah, so device type, that's the tricky part also, which is another vector that we need to solve. So how to efficiently do it, and yeah, we try to look at it. We don't want to take care of so many problems. We want to abstract and do it like a magic, like pulling a rabbit out of a hat. I want a rabbit, I pull it. I don't know, the elephant was before, like I want an elephant, I pull it out and that's it, like I don't care. Yeah, so this is the part where sometimes small extra program helps us. So we created a small device manager with simple UI, simple database, where we register all our devices and it manages our device states. So in this case, it's like pulling rabbit out of a hat. We say, hey, give us a rabbit. In this case, give me any UDM, Unified Data Machine. And it goes somewhere, we don't care there, we have abstracted that. And it gives us, hey, it's device number 3. And you have this, all these details within this response, like how you can connect to it, how you can install that, install everything, how you can access. And pipeline, as you saw it before, the pipeline, right? This is before that. So we request device from the device manager, and pipeline takes it and runs with it. So all pipeline goes for this one particular device. So we just need to in parallel iterate through all device types. And then the pipeline goes, all these tests, setups and installations, everything goes. And then we are at the end, tests are run, published, factory reset, device is ready again, and we say, oh, I'm done. Device manager, this device is ready. And device manager says, okay, this device is now free. When next pipeline will come, it will request device, and if there will be no other device available, device manager will provide this one. So it's like fishing with different bait in the pool, small pool. So you have your fishes, and you just change the bait. Like in this time, we had example with UDM. So we say, hey, give me UDM. We just take bite device type and pull out the fish, do what we want with it, put it back in the pond, and just run with it further. Yeah, and that's the summary. I will explain a little bit more of each step. But yeah, so as you saw, the pipeline is quite long. Like maybe it doesn't look so long on presentation, but actually underneath is we need to make sure that states are there, and there are a lot of process that, a lot of actions that we need to do. And the bigger the chain is, as we know, yeah, there are more potential breaking points for each point in the chain. So it's more prone to flakiness, but if our approach was to standardize more, to divide, abstract in logical chunks, that's why we have these blocks. So each block, it's run separately, we encapsulate it and work with it separately. So when we start one stage, at the end we expect that certain state for the console is there, the device is running in this particular state that we need, and we can go through all this pipeline successfully. Device variety was the challenge, number 2. So device manager solves that for us. Yeah, so we just small API request, like, hey, give me a device, and yeah, here you go, with all details, how to connect, and how we can get it. Device availability, that's another interesting one. Like, okay, we have many devices, but usually like Jenkins agent is like one. How we can solve that? Maybe any ideas? Someone have been with that problem?
Dynamic Jenkins agents?
Sorry?
Dynamic Jenkins agents versus new jobs, new agent distribution.
Yeah, that's a good idea. We have one situation where we use that, not this case. Some other ideas? Yeah, we approached a little bit simpler. We created one agent, but we extended networks with it. So each device is put in its own network. So when we ask device manager for device details, device manager gives us particular network where this device is sitting at. So it's basically like one agent, but there's layers underneath it. And we just like with elevator drive down toward a particular level and then like shake hands with it. Oh yeah, let's work together. We do our stuff and then we go back up or somewhere, go where we need, and we can parallelize it also quite successfully. Yeah, and fourth problem, that was a quite big one. I already started to tell about it in the first point. Yeah, so device state. So we need to be really sure at the next stage that previous stage has gone successfully, or we need hard fail, and that we know that, hey guys, something's not here. And since also in this pipeline it's not so straightforward, it's not everything in our team, we also have some joint collaboration with other teams, and sometimes even in different locations. So we need to be sure that each stage runs by itself, and device state is ensured. But at the end, the big deal is that we reset it, factory reset. So at the end, device is plain out of the box, just like client would do it. So all this pipeline when it goes through, it's just like client would do it. Of course, they won't install firmware, won't install network, they're just set it up. But still, we expect that something like device is shipped with some particular set of versions, and then when client opens it, he still needs to go through setup process. Setup maybe includes some firmware stuff, yes, of course, some different. Also product like level, like Unify OS, but still network is there. We have speed tests. You saw some devices with integrated Wi-Fi. So during setup, you need to define your Wi-Fi. You need to define your password. You need to define your Wi-Fi name. So when device says, oh, I'm finished setup, everything should work. Yeah, so that's our like main idea, that when you finish setup, everything just works. But here is like big asterisk. I try to make it big. So what can be a big issue when we reset device to factory defaults? Any ideas?
It loses its network configuration, so you cannot connect it.
That's one. That's one. That was also a big one for us. Yes. Another ideas?
Broken firmware?
It usually wipes everything to fresh, so it's pretty okay. Maybe steer non-functional way. Security way. No, no. Okay.
Maybe it reverts to that with the admin and password.
Sorry.
Maybe it reverts to that with admin and password. So
Yeah, that's a good one. Yeah, the default admin and password is like, it seems like simple stuff, but your devices are in company network. Yeah, so security layer, you need to always think about it. Yeah, when you reset devices to factory default, it resets back to security and defaults. So you have one potentially vulnerable vector. So devices need to be managed properly in subnets. So it has no access to some other thing, even if some malicious actor would access it and would set up for its own use. Yeah, so thank you for idea. Thank you for listening to me. Yeah, that's all from my side. This is the takeaway, and these were our like biggest challenges for now. Yeah, we're going further, expanding further. There's also, regards test-wise, a lot of things to speak about more. Like there's some performance, like vector, that also needs to be always investigated. We want to give our clients the best performance and smooth experience on that wise, big throughputs, and also device correlation. But that would be maybe for next time. So next time, yeah. So thank you. And I have one secret up my sleeve. Like, I didn't come empty-handed, and I'm really glad that you catched my drift regards the security idea. So I think that's the best answer. I'll give you a little bit. Maybe the internet is strong with you.
So you already finished these questions? Everything's answered?
That's with presentation. Questions are open.
Okay, so it's question. Now it's question.
Yeah.
And the questions?
Some questions, ideas, suggestions.
Yeah, I have a question probably about the tests. You told you have a variety of different devices, and probably if we take a look on the test step, it should also have different tests per each device. How did you solve this problem, selecting the proper test? Did you have different tests per each device, or do you have some standardized set of tests which suits every?
Yeah. So it's so base test, some kind of like subset is usually standardized across all, but there are some nuances, of course, as you noticed with the consoles. So very good question. We have something similar like feature flags. So the similar thing is with tests. So we scope them out. Some tests skipped, some tests not skipped, some extra tests, and we manage with that. But yeah, that's also another thing to think about. It wasn't so big challenge, so I didn't include it. So it seemed pretty straightforward idea in this like I think modern feature flag era, but it's basically like a feature flag similar.
Oh, I see. Thank you.
Please.
So if you request like a dream machine from device manager, it has Unify OS, and yes, you can then set it up and test it. But what if you're testing access point? It still needs a Unify OS somewhere where should we access it and use it, right? So how does test perform then?
Yeah. So access point, you can't. Well, you can, but it's via command line interface. But access point comes together with device. Like device is like controller base, and then devices are like child devices. So everything that we do with child devices, it's under console. It's a bit separate test. Yes, it's still launched in the pipeline kind of way. That's why I mentioned the board adoption test. That's the AP thing. It's super important. Our main priority is always that our client can almost instantly adopt devices. So you press adopt and you get your device AP ready, Wi-Fi extends, everything works. This seamless, smooth UX, that's our goal. We're trying to always think client first.
So how many devices do you have in your device farm? That's the first question. Second question, when doing models, hardware mistakes happen, revisions happen. So for each model, how many revisions do you keep? Do you keep only the latest X amount, only the latest one? How far back into past devices do you keep in your device farm?
So we follow just general product paths. What products we have, we keep them up, and maybe some new versions are not populated and distributed for them, but still they need to run, so we make sure they run it. The functionality supports. The test regards firmware versions, so they're always branching. So there's like internal develop branch, master branch. So at firmware, since firmware is a bit different from network, we don't take each version. So we take like the first that's deemed stable. And that's our firmware that we test with it, because the previous ones, the develop stuff, they go through their teams, some magical tests, and they found their thing there. And then we catch on like next layer on top of it, what's there. We assume that, yeah, this is stable, and we work on top of that. We put network on top and then see how network interacts with it. And we put network develop branch on there and see how that plays with this firmware. So that's regards versioning. And the third question was the device farm.
How many devices?
Yeah,
Devices. Devices, yeah. So short answer, I like not to give maybe special number, because it expands, it lowers, we swap it up, and because like for clients also devices never will be stressed so much like in our setup, right? That it is factory reset. There is also some technical issue that sometime later maybe I can give another speech about it. But yeah, so we swap it up, but the main answer will be at least two. So for development, for test development, for AQA development, we have our separate magical pipelines that reserve devices, and then we work on them daily, so to easier our process to make daily development easier and test themselves. So maybe we need to rerun something during the day. But nightly builds usually go during the night, so we have more time. Some devices boot faster, some do boot low, not so fast, slower. Yeah, so these kind of challenges that we need to account for. On first it seems simple, oh, just put weight bigger, but yeah, we need to also catch when performance dips somewhere. So it's kind of interesting, a lot of interesting approaches how to do it, but that's for another talk, I think. I'll tell that story too sometime.
Practically, what's the scope? I mean, test plan. How many test cases? What are some key, most interesting examples? How long it runs? Is it like depending on different cases?
Well, this is really hard question because the scopes are split into several parts. It's really hard to like put a finger on it because there are multiple layers. So it's like web UI, maybe some release changes more. So it's no big focus on there. Yeah, we need to also like remain or inertia and move faster forward with new features. So we focus on API. So it's very dynamical and or like tests run during night, so we have these 8 hours. That's our like big bonus at the evening when developers publish everything, version gets built, and yeah, we can 8 hours do all kind of like breaking, making and breaking, and like that, approach it. And some other?
What about compatibility matrix? Do you do any testing between different versions?
Yes, we do it, but that's outside scope of our team, so I cannot speak in specifics. Yeah. Anything else?
Seems that this is chocolate time. No.
No. Last one.
Last question. It
Speak
took
up.
some
Speak up.
time for you to come up with UDR7. For how long do you keep devices in test? Like how old devices do you have in your fleet?
Well, while it's supported, it's negotiation with product team. So, yeah, that's a short answer. It's hard to give into particularities.
Okay, and well, you had a long life cycle. Like that life cycle, the length of it's 8 hours approximately.
No, it's long life cycle. The 8 hours is the window that we can do it. Like till our work day ends, till next starts. Well, 8 hours. It's actually more, but I'm trying to drive a point across. It's more like the concept. And we have a whole night. So when we come at the morning, at the office, so we have all results. So we can investigate all day. Like, oh, how this failed, why, with all the particularities. Yeah, tests themselves don't run so much, but it's more like the complexity of this pipeline. It's not so much the time. Yes, there are some slower devices that take more time, but yeah, it's hard to say like one time.
Okay, thank you.
Yeah, that's a particularity of this zoo. Yeah, the devices are so much that sometimes there's no one particular answer. Like you need to adjust for some particular devices, and for some you can put them together into some one basket, and yeah, it works because it's powerful. You know, it's easier. But some lesser powerful, yeah, that's a challenge. Yeah, so it's like that.
Chocolate time. Thank you.